table means the tabular structure in which the elements are represented, which is like this. It is divided into 8 groups and 7 units. This is the transition elements. This is 1, 2, 3, 4, 5, 6, 7, and 8. So in Roman numeral it is still 8, but in normal numeral it is 1, 2, 3, to 12, 13, 14, 15, 16, 16, 17, and 6. So now this is divided into 7 periods, which is 1, 2, 3, 4, 5, 6, 7. This is the pattern. So hydrogen is present in the first group or first period. But we assume hydrogen in 2 places, which is in the first group as well as in the 17th group. The first group elements are known as alkaline metals, and the 7 alkaline metals and the 17 group elements known as halogens. This is the periodic table, and the hydrogen is present in the first group of the first period. Now, what is the symbol of hydrogen? How do we denote hydrogen? Hydrogen is denoted by H2. Note hydrogen by H2. The molecular formula. The valency is 1. Valency is 1. The electronic configuration is 1. Now what is electronic configuration? Suppose this is the nucleus of an atom. There are shells. So the electrons present in the shells, we tell it that electronic configuration. Suppose if there is only one atom present, so the electronic configuration is 1. If this shell will not be complete, it will not move on to the next cell. The first cell contains 2 electrons. So now the electronic configuration will be 2, 1. This way. The electronic configuration is 1. Now we have its atomic number 1. Mass number is 1 or 0, because mass number is the atomic number minus number of neutrons. So the atomic number of this hydrogen is 1. So its mass number will be number of neutrons 0. So 1. This is the formula of calculating the mass number. Now we'll see that how is this hydrogen similar to the alkali metals, means the first group elements or the second and the 7th group elements. Let us see. Here we will make it first group, and here we see the second group. First, we know that the first group has these are present in the first group, and this hydrogen is also present in the first group. Second, in the electron, these all first group elements, these all have valency 1, and hydrogen also has valency 1. Thus, all the first group elements have in their electronic configuration have 1 in the end. Either it is 281 or 2881 or 21 whatsoever, but it has 1, which is similar. Then we have the ion formation. Hydrogen, it has the atomic structure is like this. So if this donates 1 electron and gains positive charge, similarly the first group element also gain positive charge, because these are metals. These donate the electrons and acquire positive charge. Then we have the formation of the acids, like how you can say that this also has oxidizing power, this has reducing power. So metals generally have reducing power. For example, CuO plus H2 gives H2O and selina. So this hydrogen has reduced copper oxide into water and formed water. Similarly, these elements of the first group has the reducing order, like Na plus O2 forms Na2O. Now is it balanced? No. So we'll put 2 here, we'll put 2 here, so we'll put 4 here, 4 Na. Now it's balanced. So this way. Now next we have the combination with non-metals. Hydrogen easily combines with non-metals. For example, H2O. Similarly, first group elements also combine with non-metals like Na2O. Then we have NaCl. So this way it is similar to the first group. Then we have the seventh group, which is known as halogens. In this also, all the halogens have valency 1. Valency is 1 because they accept 1 electron. In their electronic configuration, they have 27, 287, means they accept 1 electron to become stable. Now, hydrogen, when hydrogen gains 1 electron, it gains the charge of negative charge. Similarly, these halogens like chlorine also gain negative charge. Now, these halogens have the oxidizing property, like suppose in this oxygen is also not only about NaCl plus O2 will give what? Na2O plus Cl2, because this chlorine will help sodium and oxygen combine with each other. So this way this will oxidize it. Now, apart from the similarities, there are two differences among the first group and elements and hydrogen, seventh group elements and hydrogen. Those are talk about the differences. We know that hydrogen has only one shell, like this. It has only one shell, hydrogen, but if you know alkali metals, it has two or more than two shells. Now, if we see the halogens, also it has two or more than two shells. Now, like if we form oxides of hydrogen means H2, this is neutral. But if we form oxide of this N2O, this is basic in nature. And if we form the oxide of this Cl plus O2, Cl2, this is acidic in nature. So this is the manner in which these are different. Now, if we move on to the discovery of hydrogen, hydrogen was discovered by Henry Cavendish, but he couldn't explain that how we can call it hydrogen. He not gave it the name. The name was given by Antony Lavoisier. First he called it this gas is inflammable air. Later on he proved it as hydrogen. Why? Because hydrogen, it is made up of two words, hydro and gen. Hydro means water, gen means producer. Means that hydrogen produces water, and this is true because hydrogen is the only element useful in the production of water. This is why it was called it was known as the hydrogen. It was as the hydrogen. Now let us move on to the occurrence. Hydrogen occurs in the free state as well as in the combined state. In the free state, hydrogen occurs in the volcanoes, but in combined state it occurs in the acids like HCl, H2SO4 and water, by which it is known as hydrogen. So this hydrogen can be prepared in the laboratory very easily. Like we can, do you all know the reactivity series? It is potassium, sodium, calcium, then magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum, gold. This. So hydrogen will displace only above this, not below this. So when the preparation of hydrogen takes place, it takes place with these elements. But in this also it leaves behind lead, because this is very less reactive with hydrogen. So it leaves it and it reacts only with 7 elements. Now let us see. First let's see for potassium. For studying chemistry, the knowing of symbols, the representation of molecules is very important. So let us see potassium first. This is potassium. Now, if we see potassium, one more important thing, the first 3 elements of the reactivity series, potassium, sodium, calcium, these all react with cold water for the formation of hydrogen. So when potassium reacts with cold water, it gives KOH plus H2. Now this is not balanced. First of all, there is, now if we take this here 2, so 4, so here 2. Now this is balance. Now when this potassium reacts with cold water, it gives out a lilac color flame with the potassium bubbles along with hydrogen is seen. Now let us see with sodium. Sodium also reacts in cold water. Na plus H2O gives Na2O plus H2. No, this equation is not correct because when these metal reacts with cold water, it gives its hydroxide instead of oxides. So I have written wrong in order to explain you all. So instead of this, it will be this. Again, same balance. Now this sodium on the reaction with cold water, it produces golden yellow color lilac flame, and again the bubbles of hydrogen is seen. This was first, this is second, now third is calcium. Calcium. Now when calcium reacts with cold water, it also gives a particular hydroxide plus H2. Now here we will take 2. Now this balanced? Yes, just balanced. Now this calcium, it returns the solution milky because the formations of calcium hydroxide takes place which turn the water milky. This is also the test for the formation of calcium hydroxide. You can say this. Now let us move on to magnesium. So these three elements, it reacts with cold water. You must remember this. Now after this we have our magnesium. So there is the special property of magnesium that it reacts with steam also and with hot water also. So magnesium reaction with steam. Now steam is also the form of water. When magnesium reacts with steam, it gives when magnesium reacts with steam, it gives magnesium plus steam. I said that steam is also the form of water. So on reaction with it, it will give magnesium hydroxide only. Plus H2 gives MgOH2 plus H2. Please add here and it is balanced. But when this magnesium reacts with hot water, it produces some color which is white, which is the, you can say, dazzling white light. Now when this hydrogen reacts with steam, just the steam is passed through. But when this magnesium reacts with hot water, it forms magnesium oxide because the hydrogen, if this is the beaker and we are heating the water and we are putting the magnesium crystals into this is completely immersed. So this will form the magnesium oxide. Is it clear? Now let us see the reaction with the other metals like zinc, aluminium and iron. Let us see with aluminium first in hot water. Okay, I have written hot water here. Aluminium. When aluminium reacts with H2O, it gives Al2O3 plus H2O. Now let us balance it. 2, 3, 3. When this zinc reacts with water, it gives ZnO plus H2. Now, there is this magic in the zinc oxide. When this zinc oxide will be hot, it will be yellow color, but as soon as it is cooled, it will turn into white color. This is a magic. Very interesting. Now, iron. If iron is placed in hot water, it will form Fe2O3. Now, here the ferric will be used. The iron with valency 3. So, because this will make this reaction reversible. This symbol is the symbol for the reversible reaction. We give H2. Okay? Now, when we are taking 3Fe means with valency 3, then it will produce magnetic oxide, which is also known as triferric tetraoxide. This means the reversible reaction. This is the magnetic oxide, and this is also known as triferric tetraoxide. Is it clear? Triferric tetraoxide. Now, let us move on to that which element is suitable for the preparation of hydrogen in the laboratory. As the scientists said, with the scientists' research, it is found that the zinc is the most preferable metal because when we use granulated zinc, it contains the copper powders which acts as the catalyst for the particular reaction, which speeds up the rate of the reaction, and it is easily available, it is affordable, reasonable. This is that's now if we take iron is it produces reversible reaction, means if we do not collect hydrogen, it will form again a reaction which will not help it to the hydrogen to be generated in more amount, because it is very quick process. We need to be full attention, and this iron is not very reasonable. Then if we take aluminium, when we immerse it in the hot water, after some time the reaction stops because the coating of aluminium oxide is formed in the aluminium, which further stops the reaction. Before aluminium, we have seen magnesium. Now, magnesium is also very expensive. Along with magnesium, calcium is also not used because of the expensive rates. Then we have sodium and potassium. Now, we know that sodium and potassium are the highly reactive metals. So, when they react with water, it is a violent reaction. So, this is why we do not use hydrogen. Now we'll be studying about the laboratory preparation of hydrogen using zinc. We have seen that zinc is the most preferable metal for the preparation of hydrogen. And not only zinc, but its granulated form is more preferable because it contains copper. So let us see. So the requirements are zinc granules, then acids, like HCl or H2SO4. So we will take a beaker, we'll pour the acid in it, then we'll add on the zinc granules. I'm donating this with this color, okay? The zinc granules, and put the stopper over here with one end like this and one end here. So we'll put the zinc granules, we'll pass on the delivery tube. We'll take a beaker. Now we'll take a flask which will store our hydrogen. Means that it will be filled with water and the hydrogen will be collected over here, and this will be attached to the thistle funnel. Now, as we pour the zinc granules into the acid, this will release acid which will pass on, this will release hydrogen which will pass on through here, and now as hydrogen is lighter than the water, it will come over here. So this way the formation of hydrogen will take place. So therefore the formula or the equation will be, we are taking H2SO4 which will give Z10SO4 plus H2. So this will be the reaction. Hydrogen is collected by the downward displacement of water as seen over here, because the hydrogen is stored here and the water is down. So this process is called the downward displacement of water, by which the hydrogen is collected. So this will give us the hydrogen. Now there are two reasons for the collection of hydrogen by the downward displacement of water. One is that the hydrogen is insoluble in water, and second is that if it will be stored over air, so hydrogen and air together will form explosive mixture, so which is very dangerous. That is why we collect hydrogen by downward displacement of water. Now let us see the impurities present in this gas. The hydrogen is collected over here, but it is not the pure hydrogen. It contains some impurities in it. And how the impurities are removed, we'll see that here. So, now, let us see that. Impurities present in hydrogen. First is arsine, second is phosphine, third is water vapor, fourth is carbon dioxide, fifth is sulfur dioxide, sixth is hydrogen sulfide, and seventh is nitrogen dioxide. Okay, now so this we can make. Now let us see how these impurities can be removed from the hydrogen. First is that the arsine and phosphine, these two can be removed from the same solution, that is silver nitrate solution. The impurities is removed only when it is dissolved, when it is put in any solution, means the process of dissolution takes place. So these solution. Then we have water vapor. Now water vapor is a form of water, means liquid. So it cannot be directly removed because hydrogen goes very well with water. So so we'll need any agent, any substance which will help us dry water vapor from the gas. So there are few drying agents, that those are fused calcium chloride, caustic potash stick, caustic potash stick. So these are the drying agent that can be used to remove water vapor from hydrogen gas. Then we have the oxides: carbon dioxide, sulfur dioxide, nitrogen dioxide. These three oxides can be removed from using the caustic potash solution or potassium hydroxide solution. Then we have hydrogen sulfide. Hydrogen sulfide can be removed using lead nitrate solution. So these are the impurities present in hydrogen, and these are the substances or the solutions by which we can remove the impurities present in hydrogen. Now let us move on to the precautions. We need several precautions which must be taken during the process when it is carried out. So first of all, the apparatus should be airtight and there should be no leakage of gas, because leakage of gas means leakage of hydrogen is very harmful. It can even cause death. There should be no flame near the apparatus. Suppose this is the glass apparatus and here the flame is there. Due to this flame, this apparatus will break, will crack. Then the hydrogen gas should be collected only after the air from the apparatus has escaped, because air and hydrogen forms a violent reaction. So hydrogen must be only collected when all the air is out of the apparatus. Then the thistle funnel which we used for the process, like this structure, then this was the flask, here was HCl and with some zinc granules, and this was the cork was there, here one delivery tube was there, and here hydrogen gas was collected and here was the water. So this is the thistle funnel. The thistle funnel should be dipped into the acid so that the gas is not escaping from this thistle funnel, because this thistle funnel has the opening. This is also one opening and this is also the opening, which is one. So that will allow the hydrogen gas to escape. So in order to prevent that, it should be completely immersed in the acid HCl or H2SO4. Now we'll see some exceptions, which are that nitric acid is also in the dilute form, in the solution form, but still it is not used in the preparation of hydrogen from the metals. Nitric acid, because nitric acid. Now what is nitric acid? HNO3. You'll see the exceptions now. Exceptions. First is that nitric acid, HNO3. NO3. If we take any metal, now this is also one dilute acid like HCl and H2SO4, but still it is not used for the preparation of hydrogen. Then we suppose we take it with zinc. What will happen? This nitric acid has this power to oxidize any compound. So it will form zinc nitrate with zinc, but it will not give out H2, rather it will give out H2O and the nitrous oxide or nitrogen monoxide. So we can balance it. 8HNO3, 3, then 3, 4 to 8, 4, and N is 8, already 2 and 3, 6 and 2. Okay, so 2 here. Now, so what is happening here? The formation of hydrogen is not taking place because this acid is oxidizing zinc. It is oxidizing the hydrogen, so it is not used. Now, but there are metals on reaction with nitric acid can give hydrogen. Those metals are, second exception is that magnesium and manganese can give hydrogen gas using nitric acid. How it is? Suppose you take magnesium plus HNO3 will give MgNO3 2 plus H2. This will give, so it will easily react with the nitric acid and give out hydrogen. In this case, the nitric acid is not get oxidized with hydrogen, so it gives. Same as with manganese, Mn plus HNO3 gives MnNO3 2 plus H2. Same reaction. The third exception is that concentrated sulfuric acid is not used in the preparation of hydrogen gas because it is also an oxidizing agent which produces sulfur dioxide and water instead of producing hydrogen. So let us see with that. Suppose we take Zn plus H2SO4, it gives zinc sulfate plus SO2 plus H2O. Let us balance it. 2 to 4. So here also 2. And let us see 2 to 4, 8. 4 to 6 to 8. Yes, it is balanced. So this reaction is forming SO2 and H2O instead of H2. So this is nice. Then how we will detect that the hydrogen gas is only formed? Because hydrogen is colorless. Hydrogen is a colorless gas. So how we will detect that whether it is hydrogen only or some other gas? So there are two tests for hydrogen. Let us see those tests. Tests for hydrogen. Hydrogen burns very easily, but it will not support burning. Suppose if this is the flame and here the hydrogen gas is evolved. Itself it will burn. Itself it will burn, but it will stop this burning of the flame. First test is that hydrogen is combustible, but does not support combustion. Now, second is that if hydrogen burns in the air, it burns with a silently, but it will change the flame. Suppose if we are passing heat, and the flame is of normal red, orange, yellow, orange color, but this flame will turn into blue flame, with the formation of water. But when this is again mixed with oxygen, means when 2H2O burns again with oxygen or air, heat, it burns with a pop sound. It burns with pop sound. This is a trick of balancing. So this is if we take it to this also 2, we go to this also. It will give multiplied by if we 4 here to 4 to 8, 4 to 6. Okay. So it will give, when this is burning, it will give 4, 2. Okay. So this will be the formation of the hydrogen of water with pop sound. So this is the test for hydrogen. Next we have how can hydrogen be formed using non-metal, which is carbon. When we take carbon or coke, you can say coke, and pass steam, means H2O, at 1000 degrees Celsius. The temperature is very important because at this temperature only it forms hydrogen. Not only hydrogen, but CO plus hydrogen, which collectively is known as water gas. The preparation of hydrogen using this is the first step. Then we have the second step. We pass steam again through this water gas, which is CO plus H2. Again, if we pass steam at 450 degrees Celsius along with the catalyst ferric oxide Fe2O3. It forms carbon dioxide and 2H2. Is it balanced? Yes. Now, this reaction, it takes a lot of heat. So this is endothermic reaction, but this reaction, it gives more heat. So this is exothermic reaction. If we see here in the second, we are getting carbon dioxide along with hydrogen. Now, as both are the gases, both will be mixed together. So how we'll remove the carbon dioxide from this? Removal of carbon dioxide from CO2 plus 2H2. How we'll remove it? First step is that we'll dissolve this mixture in water. We'll dissolve CO2 plus 2H2 in water. So in water, CO2 is soluble, so it will leave behind H. Second step is that we'll use caustic potash solution. Means that we'll take KOH plus CO2 plus H2, we'll 30 atm. In this we'll take the 30 atm pressure. We'll pass this through this solution, which will give a salt, which is K2CO3, H2O and hydrogen. This is 2 to 4. Yeah, this is correct. H2 and 2, 4. Yes. So this will be the process of the removal of carbon dioxide from the mixture of carbon dioxide and hydrogen given out when we manufacture hydrogen using non-metal, which is red hot coke, and this complete process is also known as Bosch process. Bosch process. Process spelling. Now we'll see oxidation and reduction. So this is oxidation and reduction. Means if in any substance oxygen is added, it will be oxygen, and if in oxidation, if in any substance hydrogen is removed, or there is the addition of negative ion or the removal of positive ion, in that case it will be oxidation. But in opposite case, that is removal of oxygen, addition of hydrogen, addition of positive ion and removal of negative ion, this will be reduction. There is a simple trick, that is oxidation is losing and reduction is. Let us see some reactions, because we have half reactions or redox reaction also. So redox reaction is the reaction in which oxidation is also taking place and reduction is also taking place. So let us see some reactions, then it will be more cleaner. Okay, so let us suppose we have Fe plus Cu2 plus gives Fe2 plus Cu. Now, here nothing means 0. Here nothing means 0. Now, what we'll do, we'll take single elements, which is that if we take Fe, put it in the same place and give Fe2 plus. Again, we will take Cu2 plus, leave some space, give arrow, write Cu. Now, here what I said, nothing means 0. And if we see here, it is gaining 2 plus. In the time, or we can say 0, 1, 2. Okay. If it goes up means oxidation. If it goes down means reduction. Now from 0 it is going up to 2 means it is oxidation. And in oxidation the removal of negative ion takes place. So we will write negative. But here it is 2. So we will write 2. This is the half oxidation reaction. Now if we see this here 2, here nothing means 0. From 2 it is going to 0 means decreasing, so reduction. In reduction the addition of the negative, electrons in the addition of the positive charge. So we'll now what in this is one reaction, so whatever this will lose the other one will take. So this is taking 2 electrons and giving, means from 2 is going to 0 because it is taking 2 electrons. So this is oxidation, this is reduction, and this is the redox reaction because in this both oxidation and reduction is taking place simultaneously. Now, oxidizing agent. Oxidizing agent. These are the substance which oxidizes the other substance and reduces itself. Once again, these are those substances which oxidizes others. Oxidizes other, reduces itself. See, so in this reaction, which is getting reduced itself and oxidizing the other. See here, this is adding, this is getting reduced because in reduction what was said, the addition of the charge. See, addition, here addition. So this is carrying out the process of reduction, and means this is getting reduced but it is oxidizing what? C. So here in this case Cu2 plus is the oxidizing agent. If we see reducing agent, sorry, this oxidizes itself, reduces other, oxidizes other. This is oxidizing this Fe and Fe. Now now in this reaction, which element is reducing the other element? Cu2 is getting reduced by whom? Fe, because Fe is taking the electrons. So here the reducing agent will be Fe with no charge. So this is the reaction. Now I'll take one more example. Cu2 plus gives Zn2 plus C. If we take one element, okay, Zn gives Zn2 plus, here let's write Cu2 plus gives C. Now here the maximum is 2, so we'll write 0, 1, 2. Here nothing means 0, 0 to 2, 0 to 2. It is going up. Up means what? Oxidation. From 2 to nothing means 0. Check down. So reduction. So means this is oxidation and this is reduction. So this is the case. Now oxidation means removal. How many? 2. Reduction means addition of how many? 2, 0. But we do not write 0. Just for our understanding purpose, we write 0. Now, oxidizing agent and here reducing agent. Here oxidizing agent and then reducing agent. What is getting oxidized? Oxidizing agent means itself it is getting reduced, but it is oxidizing others. And reducing agent means itself it is getting reduced, but it is oxidizing the other. So in this reaction, which is like here, if we see Zn further what it is taking, it is means it is carrying out the process of reduction. Itself it is getting reduced, but it is oxidizing the other. So here Zn will be oxidizing the agent. If we see this Cu2 plus has nothing further, means it is losing. So it is carrying out the process of oxidation, means it is oxidized but it is reducing others. So this will be either reducing agent. Okay. So as we have come to this end of this chapter, and if you all have any doubt, you can comment in the comment section. Thank you.